Okay, 1.5, shifting, reflecting, stretching graphs. Shifting, reflecting, stretching graphs. Okay, we're going to talk about 6 different types of graphs. What type of graph is this? What type of graph is that?
Line graph.
A line graph, a linear function. Good. Linear, it's represented by f of x equals x in its simplest form. What type of graph is this? Not a parabola, it doesn't have a rounded.
Not a parabola.
It goes,
Function.
starts with an A, an absolute value function.
What the?
I'm sorry.
Absolutely.
I can't hear you.
Yeah.
I hear you. And its form, simplest form is f of x equals the absolute value of x. Then we have a graph that looks like this. Anybody remember what type of graph that is?
Curve.
That one is a square root function. And its simplest form is f of x equals the square root of x. We also have this type of graph. What type of graph is that? You said it before.
Oh, a parabola.
Yeah, it's a quadratic function, a parabola.
Parabola. Parabola.
Quadratic, and it's represented by f of x equals x squared. And then the last function, oh no, we have 2 more. 2, 4, 6, okay. Then we have a function that looks like this. We actually did all of these functions last year, FYI. Yeah. Remember when you guys had to do the wiki pages last year?
We had a wiki page?
We did.
Say
Yes,
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 We didn't
yes, we
do
did.
that.
Uh-huh.
For this class?
I don't think we did that.
I don't think we did
Oh my
wiki.
good lord, guys.
Oh, we might not have gotten to that last year.
That was too slow.
I'll double check. If not, we'll do it
Maybe
here this
Lindsay's
year.
last.
Oh.
No, we definitely did one last year.
We
are Yeah,
100% do.
What type of
I remember
function?
now.
What type of function is this? Cubic. And it's f of x. You guys need to learn how to take a hint from Matthew a little bit better. Equals
being
x
stupid.
cubed. And then the last one is a function that looks like this. What type of function is that?
Sorry, Matthew.
Parallel.
A rational function.
What irrational?
With f of x, hey, Matthew started off the way with the line, so he did great. Equals 1 over x. Those are the 6 functions we are going to look at. Those are the 6 functions. We're going to talk about shifting, reflecting, and stretching. Okay? If I have a graph that says, let's see here, let me think about this. If I have a graph that says f of x equals x squared plus 2, what is happening? First of all, what type of function is this? If it says x squared plus 2, which of those 6? A quadratic. And what does that 2 do to my function?
Moves it up to.
It moves it up 2. So it starts here instead of at 0, 0. Okay? This is what we're going to look at today. How to graph all of these things. What happens if I have this equation? G of x equals x minus 2 squared. What type of function is that? What type of function is that?
Is it one of these?
It is one of those.
Quadratic.
It is quadratic again. What does this 2 tell me?
It's gonna go down.
Square.
Not down. It's going to move to the left or to the right 2. It moves opposite of what that sign is. So instead of starting here, it's going to start here and come. Okay? We're going to do a lot of these like little rough sketches of things today in your homework. Vertical and horizontal shifts. There are 4 rules for vertical and horizontal shifts. And then it will tell you how to do it. And these can apply to all the graphs. Vertical and horizontal. Okay. Vertical and horizontal shifts. Number 1. It goes upward, if you have h of x equals f of x plus c, okay? Like we did in that first one. The second one is it goes downward. If you have h of x equals f of x minus c. Function minus c. Third, it can shift to the right. If you have h of x equals f of x minus c within the parentheses. And then the fourth one is it can go to the left, and that is when you have h of x equals f x plus c in the parentheses. So it tells me if it's going up or down, left or right, according to where it is. And that can apply to all of our graphs. So if you have a graph that says x cubed, f of x equals x cubed minus 1. First of all, what type of graph is that going to be? What type of graph is that going to be?
Cubic.
Cubic. And what's going to happen to it?
Go downward.
It's going to go down 1 unit. So instead of starting here at 0, 0, it's going to start at -1, and it's going to come and go like this, and then its turning point's there. Okay, so the graph shifts down 1. What happens if you have this? Let's say we have g of x equals, and then we have x plus 2 cubed plus 1. What is that graph? What type of graph is it, and what's it going to look like?
Cubic.
Yep, cubic, and then what else? What happens shift-wise to it?
It's gonna go up
to the
one
right.
and to
It's
the
going to go
left.
up 1 and to the
Right.
left.
Oh, wait, this one is opposite.
It's opposite when it's inside.
What if it's opposite, wouldn't it go?
No, because it's not positive, so it's not going to the positive side, it's going to the negative side. I'm going up 1, see, when it's plus c inside, it goes to the left. So I'm going up 1, I'm going over 2, and this is where my starting point is. And my graph comes. Okay. That's some shifting and some of the shifts that we do. The other thing we can do is reflections. Reflections, okay? If you have a reflection, the first type of reflection, bless you, is in the x-axis.
Would you like me to?
Sure. Just set it on my desk. Just a regular one. Is the x-axis. So it's h of x equals negative function of x. Okay, so if it's reflecting in the x-axis, it has a negative outside of the function. If it's reflecting in the y-axis, it has a negative inside of the function. Okay, it's applied inside of the function, not on the outside of the function. Okay, so if it's reflected on the inside of the function, that means that it is going to turn left or right. But if it reflects the outside, it's going to flip up or down. Okay. So if you have a function that says, let's say we have one that says h of x equals the radical negative x. What type of function am I graphing? Square root. And if it's a square root and has the negative on the inside, what type of reflection is happening?
Reflection.
Y-axis.
Y-axis. So instead of it going this way, it's going to reflect over the y-axis and go this way. Okay, because my parent function shows that that function goes that way. So if I reflect it over the y-axis, you're going to get used to it. I don't know if you have to memorize all of it, but I'll probably on your test give you a page of the parent functions, and then you're going to have to compare it to those. Okay. So yeah, that's pretty much what we are looking at today. That's pretty much the whole thing. We'll spend 2 days on this.
That's all she wrote.
So on Monday you'll get more practice.
Yeah.